Hi, I'm Paul. This is Science That Sticks. Today I'm using sticks for Science That Sticks. Yes, that's cheesy. However, I'm behind my drum kit, and in a moment I'm going to show you a few things. This lesson, this session, whatever you want to call it, this video is about sound. The difference between loud and quiet, what causes a sound, what happens with vibrations, and when you look at a cymbal and it moves to and fro, what happens? How does that make a noise other than the fact that you hit it and a noise comes from it? What's the business with all that? Well, the simple answer to all of those questions is that sound is created by vibrations. Something hits against something else and it creates a vibration. Now, a vibration basically is any object or anything that moves from one place to another and back again. Sometimes it's just one hit and that creates an airwave. Now that airwave is created by a compression and a rarefaction, both of which are required for a sound wave to travel out in all directions. Now you can't see a vibration with just one hit, not on a stick, but you can on a cymbal. Now I'm going to show you a couple of cymbals being hit, and then what I'll do is I'll slow them right down so that you can see the compression and the rarefaction, or at least the movement to and fro, and that movement up and down, to and fro, whatever, is going to be the frequency. The more that it moves, i.e. the faster that it moves to and fro, the higher the pitch. Moves a lot quicker in that instance. But of course, it's not just the movement up and down. How big the cymbals are also has an impact on this. So let's go to a full shot of the kit and find out which pieces of the drum kit have the highest tone and the lowest tone, and therefore we can start talking about vibrations. What we'll also look at is the difference between quiet and loud. Let's get to it. So on the drum kit I've got a 14-inch splash, a 16-inch crash, a 18-inch crash, and down here I have a 20-inch ride, which allows me to sort of play the rhythm, but I can also play the rhythm on a pair of hi-hats which are 13 inches. Now each one of them, because they are a different size, will give a different pitch when hit. Now of course this lesson is not about pitch, it's about loudness and quietness. Now you can play a drum kit very, very loudly without really trying. Let's check this out. Now because the drum kit is naturally loud, it doesn't take a great deal of energy to make a loud noise. Every part of the drum kit, whether it be the bass drum, the snare, one of the toms, all of them use the same mechanism to make the sound wave. You hit them, there is friction, one thing hits another, the skin vibrates and this creates a sound wave, or the metal vibrates and this creates a sound wave. So if we play lighter with not much energy, then we decrease the amount of sound and we become a lot quieter. Now if I really, really decrease the sound, I could play very, very lightly, hopefully at the same tempo, and therefore you are able to hear more of the notes because it's not as mixed through the little microphone there. So let's try this. Now, let's also really concentrate on what a vibration is and how a cymbal can help us identify compressions and rarefactions. So let's go to the hi-hat here. As the cymbal moves up and down, the cymbal, when it goes up, compresses all the air particles. As it moves down, it gets away from them. As it returns back into the up position,
then those air particles are moved away. This continues to happen thousands of times a second, which is why you end up hearing a sound wave.
And so there you have it. When the cymbal is struck, it vibrates up and down, up and down, up and down, and as it does so, it creates air compressions above the surface and below, and as it moves back up, that air compression is moved along, and the space in between those compressions is called rarefaction. That creates the sound wave. That's why you can hear the cymbal. Till next time, ladies and gentlemen, stay cool. Goodbye.